morning, everybody. Myself, Raghubir Singh, lecturer in civil engineering from Pandit Jagatram, Government Polytechnic College, Hoshiarpur. So today, in the subject of fluid mechanics, we will see and discuss a very important topic, the measurement of pressure. And let's have a look what are the different contents of today's topic. We will start up with some basic definitions, some technical terms related to fluid mechanics. Then we will have a look on different types of pressures, the atmospheric pressure, the absolute pressure, vacuum and gauge pressures. Then we will move on to the manometers regarding the measurement of pressure. What are the different type of manometers, simple manometers and the differential manometers. And in the last we will see the mechanical gauges, the three different type of mechanical gauges, the Borden's two pressure gauge, diaphragm pressure gauge and dead weight pressure gauge. So before moving to the measurement of pressure, we will discuss some basic terms in the fluid mechanics, starting with the density, which we also call as the mass density. The density of a fluid may be defined as the ratio of the mass of a fluid per unit volume. So it is generally denoted by a symbol rho, and mathematically we write density or mass density as mass of the fluid upon volume of the fluid. So as far as the units of density is concerned, the unit of density is SI units is kg per meter cube, and the density of water at 4 degrees centigrade at mean sea level, it's 1000 kg per meter cube. One more term related to this density called the weight density. So weight density of a fluid may be defined as the ratio of the weight of a fluid per unit volume. So it is weight upon volume, also called the specific weight. So that this is the second name for weight density, specific weight, denoted by small w. Mathematically, we can write weight density as weight of the fluid upon volume of the fluid. And the units of the weight density in SI is Newton per meter cube, and the specific weight of water at 4 degrees centigrade at mean sea level, it is 9810 Newton per meter cube. So if mass density is 1000 kg per meter cube, the weight density of water it is 9810 newtons per meter cube. One more property of a fluid, the specific gravity. So specific gravity, it is defined as the ratio of specific weight of any fluid to the specific weight of a standard fluid, generally denoted by capital S. So mathematically we can write specific gravity as specific weight of a liquid upon specific weight of a standard fluid. Now what is this standard fluid? In the cases of liquids, we take water as a standard liquid at 4 degrees centigrade, and if it is in the case of gases, so the standard fluid is taken as air at 0 degree centigrade. And as far as units of specific gravity are concerned, it is dimensionless and it has no units. So moving to the pressure part, the pressure is the force exerted by a fluid per unit area. So pressure is also called sometimes the intensity of pressure, denoted by this symbol small p, and mathematically it can be written as capital P upon A. So pressure is force upon area. Since the units of force is newtons and the units of area it's in meter square, so we can write the units of pressure or pressure intensity as newtons per meter square. And there is one more term which we call as Pascal, denoted by capital P and small a. So this 1 Pascal is equal to 1 Newton per meter square. So we can use any of this term, Pascal or Newton per meter square. Moving to the types of pressures, the first one is atmospheric pressure. Atmospheric pressure, it is a normal pressure exerted by atmospheric air upon all the surfaces with which it is in contact with. So, the normal pressure which the atmospheric air is exerting on us, it is the atmospheric pressure, also called the barometric pressure. Atmospheric pressure is also called the barometric pressure, measured by an instrument called barometer. And regarding barometer, one interesting thing is that this instrument registers the height of the column of any liquid. So, in barometer, the readings which we generally get, it is in terms of height of the column. It is in meters, mm or centimeters, and this atmospheric pressure at sea level, it is called standard atmospheric pressure. So, this term is interesting, the standard atmospheric pressure. And as I just told you that this atmospheric pressure is measured by barometers, the instrument registering the height of the column of any liquid. The standard atmospheric pressure, it has some equivalent values at sea level. Let us see what are these values. The first one is 101,300 newtons per meter square, or 1.013 bar. So, this is the first equivalent value of atmospheric pressure. The second one, the 10.34 meters of water, or 760 mm of mercury. So, these three values are indicating the value of standard atmospheric pressure. We can use any one of them whenever we solve the numerical part, but most of the time this value is very prevalent, 760 mm of mercury or Hg, or we may convert it into meters as 0.76 meters of mercury, and we can use as a standard value of atmospheric pressure. Moving to two different types of pressures, the gauge pressure and vacuum pressure. Now, what is gauge pressure? We have just seen a term atmospheric pressure. So, relating this gauge pressure to the atmospheric pressure, the pressure which is more than this atmospheric pressure is called, or it is known as, gauge pressure. So, very simple, gauge pressure has value more than the atmospheric pressure, or it is also called the positive pressure since it is on the higher side. So, keeping atmospheric pressure as a datum. Now, this point is clear, it will be clear from the coming diagram that what does this mean, that keeping atmospheric pressure as datum. But you can just have a look that what is the definition of gauge pressure. It is a pressure more than the atmospheric pressure. Now, regarding the vacuum pressure, it is in the reverse side of gauge pressure. The pressure which is less than the atmospheric pressure is called vacuum pressure, and since it is on the lower side, so it is also called the negative pressure, and one more term, suction pressure. So, we have three names of vacuum pressure: vacuum, negative and suction pressure. The fourth term related to pressure, absolute pressure. Now, what does this mean? What is an absolute pressure? Firstly, absolute pressure is defined as the pressure measured above absolute zero pressure. It is measured above absolute zero pressure, and very important, this absolute zero pressure exists in complete vacuum. We are very much known with this term vacuum, that the place where there is no air, the space having no air is called the vacuum part, and this absolute zero pressure can exist in complete vacuum. So, mathematically we can interrelate all these four pressures: the absolute one, atmospheric, gauge pressure, vacuum pressure. What is the relation between these four? The first one is the absolute pressure P1, it is atmospheric pressure plus gauge pressure, the first relation. of these three pressures. Absolute pressure is equal to atmospheric pressure plus gauge pressure. The second one, absolute pressure P2, it is equal to atmospheric pressure minus vacuum pressure. It will be more clear from this particular diagram. Now, this horizontal line at the base, this is indicating the line of zero pressure. This line is the line of zero pressure, and this particular line is indicating the datum level. It is atmospheric pressure line. So let us suppose I am interested to calculate the pressure at P1, the absolute zero pressure, absolute pressure at this point. This particular line is indicating the atmospheric pressure. So from here to here, this arrow is the barometer measuring atmospheric pressure. This line is indicating the atmospheric pressure. And we have just seen the point here, it is the gauge pressure. The gauge pressure is the pressure which is more than the atmospheric pressure. So from this atmospheric pressure till here, it is the gauge pressure, and this particular point, since it is less than the atmospheric pressure, so this is the vacuum pressure. It's very much clear. Taking this line as a datum line, this is a gauge pressure and this is vacuum pressure. Now, if I am interested to calculate the absolute pressure here, so it will be atmospheric pressure plus gauge pressure, which we have just seen. Absolute pressure is atmospheric pressure plus gauge pressure. And the second relation, if I am interested to calculate absolute pressure here, it will be atmospheric pressure minus vacuum pressure, as you have seen here. Absolute pressure is equal to atmospheric pressure minus vacuum pressure. So we have four different levels. This is the zero pressure level, atmospheric pressure as a datum level. This is the point where we can see the gauge pressure, and here the vacuum pressure, and we can make a relation between all these four. One more thing, P1 is the point here. It is the point which is greater than this point, P-ATM. P-ATM means the point of atmospheric pressure. This is greater than this P2, as it is indicated here also, and this 0 is indicating this first level, the zero pressure level. P1 is greater than P atmospheric, P atmospheric is greater than P2, and P2 is greater than zero pressure level. So this is all about these four different type of pressures: absolute, vacuum, gauge, and atmospheric pressure. Now I'm interested to discuss regarding the measurement of pressure. How do we measure the pressure by different instruments? So in the measurement part, the pressure of a fluid is measured by following two type of devices: the manometers and the mechanical gauges. Firstly, the manometers. Now manometers are the devices which are used to measure the pressure at a point in a fluid. So to measure the pressure at a particular point in a fluid, it is always advisable to use this device, manometers. Now manometers are again also, it is of different types, we will discuss just now. Regarding mechanical gauges, now these are the mechanical instruments, the devices. These are particularly used to measure high fluid pressures. Now it's not possible in the case of manometers. Mechanical gauges are specifically measuring the high fluid pressures where tube gauge cannot be conveniently used. Tube gauge means the manometers. Where these manometers cannot measure the pressures, mechanical gauges are very fruitful there. So we can measure high fluid pressures with the help of these mechanical gauges. We will see one by one. Firstly, the manometers. Manometers are defined as the devices used to measure the pressure at a point, as I just told you. Now, manometers are also used to measure the difference in the pressure between 2 points in a pipe. Suppose in a particular pipe we have 2 points and we want to measure the difference in the pressure. This can be done with the manometer. Or suppose you have two different pipes, so to measure the difference between those two pipes, once again manometers can be easily used to measure the pressures. Now, how do these manometers work, on which principle it's based on? So, manometers are based on the principle of balancing the column of a fluid by the same or another column of the fluid. Column is what? It's the height. So, by balancing the height of a particular fluid by the same fluid, like water by water, or by another column of the fluid like mercury with the water. So, we have two concepts here which are discussed in the manometers further. Now, in the classification of manometers, first are the simple manometers, which are again are of three types: piezometer, U-tube manometers, and single column manometers. The second type of manometers are differential manometers. These are again of two types: U-tube differential manometers and inverted U-tube differential manometers. We will see one by one. Firstly, the simple manometers. Now, simple manometers measure the pressure at a point of a fluid in a pipe. This is repeated once again. Simple manometers measure the point at a particular point, pressure at a particular point of a fluid in a pipe or in any container. Secondly, simple manometer consists of glass tubes. Now, this is interesting. Simple manometers consists of a glass tube, one end of which is connected to the point at which pressure is to be measured, and the other end is open to the atmosphere. Now, it will be clear from the diagram. As you can see, the first type of simple manometer, it is the simplest form of manometer, the piezometer. Often we use the terms piezometric tubes. So, it's that term comes from this piezometer. It is the simplest form of manometer and it is used to measure moderate gauge pressures. Now, this is the special quality of this piezometer. It is measuring moderate gauge pressures, not the high pressures. The moderate ones can be measured very easily with these piezometers. Now, one end of the glass tube is connected to the point where pressure is to be measured. Now, this is the point A, where it is required to calculate the pressure, and the other end is open to the atmosphere. This is what we have written here, that one end of the glass tube is connected to the point where pressure is to be measured, and the other end is open to the atmosphere. Now, keeping in mind, this piezometer cannot be used to measure the negative pressures. Now, this is, you can say, the limitation of this piezometer. If it is used to measure moderate gauge pressures, it cannot be used to measure negative pressures. For negative pressures, we have another instruments, and also for measuring the pressures of the gas. For measuring the pressures of the gas, once again, this piezometer is not at all advisable. So, in this particular case, this is a case of moderate gauge pressure. Now, I am interested to calculate the pressure at A point. So, the pressure at point A, it will be given by W into H. Now, this small w is the specific weight of this particular fluid, and H is the difference of height from here to this point A. So, this H multiplied by the specific weight of this liquid, we can calculate the pressure at this point A, the simplest example of simple manometer. Moving to the second type of simple manometer, we have U-tube manometers. As its name is indicating, U-tube, the shape of this type of simple manometer, it is in this shape of a alphabet U, as you can see here also. So, it is again consisting of a glass tube bent in U shape. Again, one end of this tube is connected to the point at which pressure is to be measured at point A. We are interested to calculate pressure at point A, and the other end is remaining open to the atmosphere. Now, in this particular case, you can see in this diagram, till here we have different liquid, its fluid density is rho. We have different liquid. From this point till here, we have a dark liquid. This particular liquid is called manometric liquid. I am repeating it once again. This liquid is the different one whose pressure is to be measured at point A, and from here till here we have a different liquid. In this diagram, it is denoted by a dark color. This liquid is called manometric liquid. Second thing, the specific gravity of this particular liquid is always more than the specific gravity of this liquid. So, we often use mercury as a manometric liquid. This is rho man. Rho man means fluid density of a manometric liquid. This is simply rho. This is the fluid density of this simple liquid. So, repeating once again, the tube generally contains a liquid called manometric liquid having specific weight greater than the liquid of this particular point where pressure is to be measured. So, this is second type of simple manometer. Moving to the third one, the single column manometer. Now, it is very much similar to the U-tube. In fact, the change is here we have introduced a reservoir here. So, it is also used for measuring small pressures, but very important, where accuracy is of much importance. So, single column manometer is used where accuracy is of much importance. Now, it is a modified form of U-tube. It is also a U-tube, but there is some modification here. A reservoir is connected to one end of the limbs. This is one limb, this is another limb, and the cross sectional area of this area of reservoir is much larger than the cross sectional area of this limb. So, here is the change. We have introduced a reservoir. This dark red color is indicating the manometric liquid, and these dotted dots are indicating the second liquid, the liquid where it is desired to measure the pressure. So, here we are interested to measure pressure at this point A. From this A to this XX section, let us suppose the height is h1, and from this manometric liquid, from this point, so there is a correction slightly here, this h2 is till here. Why? Suppose this is h2, and h2 minus h1, this small region, it is denoted by delta h. So, if I am interested to calculate the pressure at point A, it is given by the formula delta h, the difference in the pressure of h2 minus h1, the difference in the heights h2 minus h1, and s2 minus s1, where s2 is the specific gravity of this manometric liquid and s1 is the specific gravity of this simple liquid, plus h2 s2 minus h1 s1. So, this is a slightly different formula to calculate the pressure at point A. So, these are the three different type of simple manometers: the piezometer, U-tube manometer, and single column manometer. So, these are three different types of simple manometers. Now we will see the differential manometers. How these differential manometers are different from simple manometers, we will see here. The differential manometers are the devices used to measure the difference of the pressures between 2 points in a pipe. If I am interested, suppose this is a fresh water, this is a seawater, and I am interested to calculate the difference of pressure at this point and this point. I cannot use the simple manometer here. So it is always advisable to use the differential manometers here to calculate the differences of the pressure between 2 points in a pipe or in two different pipes, as it is in this case. Once again, differential manometer consists of U-tube made up of glass. The two ends of the U-tube are connected to 2 points. No point here is open to the atmosphere. It is a closed case here. So the two ends of the U-tube are connected to the 2 points. This is the first point, this is the second point, where difference of pressure is to be measured. So this is the basic introduction of the differential manometers. Moving deep into it, these are basically are of two types. Two common types are U-tube differential manometers, just like we have U-tube simple manometer, and one is inverted U-tube differential manometer. We will see one by one. The U-tube differential manometer, as you can see in this case, how it is different from simple manometer. In simple manometer, we have tube and one part is open to the atmosphere. But here, in the case of differential manometers, we have two different points. One is A and there is B. And I'm interested to calculate the difference in the pressure of A and B, what I write here as HA minus HB. Well, let's see something about it. We have two cases here. This first fluid A and B, these are at the same level here. So we will say two cases. This is the first case. This shows a differential manometer whose two ends are connected with two different points A and B at the same level. And we have a second case also when these are at the different level. As you can see, this is on the higher side, whereas point B is lower down here. So we will see one by one. The first case, when these are at the same level, difference in the pressure head at A and B is given by, now let us suppose in this tube A as well as in this tube B, both the liquids are same, as it is indicated by the red dots in both these tubes. And we have manometric liquid here with the dark red color. The specific gravity of this manometric liquid is S. This S is the specific gravity of this manometric liquid. This S1 is the specific gravity of this liquid at A. S2 is the specific gravity of liquid at B. But since in this case both these liquids are same, so that's why we have S1 is equal to S2. So writing down the formula, in this particular case, the difference of the pressure at A and B is given by H S minus S2. And what is H here? It is this height, the difference between this level and this XX section level. This is H. So this is the first case. What these abbreviations are indicating: HA, it is the pressure head at A in terms of head of water. HB, it is the pressure head at B in terms of head of water. H, it is the difference of levels of the heavy liquid in the U-tube. S is the specific gravity of the heavy liquid, which I am calling here as the manometric liquid or mercury. S2 is the specific gravity of the liquid in pipe B. Now in the second case, when these are not at the same level, the formula slightly changes. Suppose here pressure is more and here the pressure is less. So HA minus HB is given by S1, the specific gravity here, H2 minus H1, this H2 minus H1 plus H into S. All the terms or the terminology is the same which we have just seen here. So these are the two cases of U-tube differential manometer. Now moving to the inverted U-tube differential manometer. What is invert? It is reversed. As you can see, this is the inverted U-tube manometer.